So as we were mentioning today that for lane management, we have three strategies: the shoulder lane, the HOV lane, the lane reversal. And as I mentioned, in case of lane reversal, you have the right of way and you can recustomize it. So you don't stick with an even number for number of lanes. You can have an odd number of lanes. And the additional lane, this is going to be the lane that is going to be switching between the two directions. Any questions? Okay, here are some definitions for the lane management and the stuff like that. We are not going to elaborate on here on this. This is an example for shoulder lane that during normal traffic we have only one lane, but during congestion we add this lane. These are signs which are basically LCD signs. Okay, it turns on when there is a need for it, so you have this channelization like this. So yesterday we started discussing the traffic calming. What do we mean with traffic calming? One of you was asking yesterday. We mean with traffic calming that we need to force drivers to slow down, basically. Okay, so why we need to do that? We need to do that to improve safety, okay, in residential areas. So we don't want someone, driving their car at high speed in a neighborhood. Clear? So here it says the definition. What is traffic calming? Traffic calming measures are physical road design elements and non-physical. So we can achieve that goal either using physical road design elements, okay, like speed hump, speed bump, narrowing the street, making lane closures, whatever. And we can achieve that with non-physical measures, like having speed enforcement radar or informative radar signs and stuff like that. So basically the objective of traffic calming is to improve safety and quality of life for residents in a residential area by reducing the impacts from speeding vehicles, from cut-through traffic, and careless drivers. Those are basically the sources for all kinds of traffic accidents and problems. The results will be reduced speed, reduced number of accidents and severity of collisions, reduced cut-through traffic, and better environment for residents and for business owners as well. So, for traffic calming, we have a toolbox. This toolbox covers these categories. We have 5 categories. We start with non-physical measures. Okay, this category, we don't need to have a construction contract for someone to go to the site and change the physical structure of the road. Okay, the other 4 measures, these are physical measures. For example, narrowing measures, horizontal measures, vertical measures, and diversion devices. And we will discuss each of these carefully. For example, for the non-physical measures, this including reduced obstructions that limit drive visibility, signage, and striping improvements. Okay, but for the narrowing measure, we have including pulp outs, chokers, and center island narrowing. Okay, so these are means to shrink the road width or the travelway width for vehicles. So this is one of the measures to force drivers to reduce their speed. The horizontal measures include traffic circles, roundabout, and chicanes. Chicanes, these are not very common, by the way, okay, but the most common are roundabouts and traffic circles. They force drivers to slow down. The vertical measures you can say that it's 90% of vertical measures are in speed humps and speed lumps. Okay, the divergence measures, these basically for cut-through traffic. Either it's partial and full street closures, either partial closure for a street or full closure for that street. Clear? Then we discussed that for each problem there is an effective measure. So these measures are not suitable just for any problem. Here we have for each problem, we have a traffic calming strategy that better suits it. For example, if we have the common problems are usually speeding or traffic volume, vehicle safety, pedestrian safety, noise, and vibration, air pollution in the area. So these are the major 5 problems that we need to do traffic calming to handle. In this table, we discussed that for this of problems, if the problem was speeding, so these measures with black dots are feasible to implement. Okay, for example, target speed enforcement, radar trailer, and so on. All these are useful according to this solid circle or half circle and empty circle. Empty circle, that means it's the least efficient. Okay, a half circle, it's 50% efficient. Full circle, it's efficient. Clear? Of course, to deploy these measures, there is a constraint for it. For example, you cannot put a vertical measure like a speed hump or speed lump, okay, on King Fahd freeway. Clear? But what can we do in case of King Fahd freeway, for example? If we want to do some traffic calming.
Like Sahir, Doctor.
Exactly. Okay, so it's speed enforcement. All are non-physical measures. Speed cameras. Okay, so if we go, for example, for a collector road, what can we do? Like, for example, Khalid ibn Walid Street الخبر.
كان نحط هو شارع عام دكتور اللي تقصده هذا؟
سبيد بامب.
أنا بغيت أقول مطبات بس ممكن الشارع إنه عام صح؟
اللي هو شارع تجاري حق الراكة.
شارع تجاري في الراكة. يس.
سبيد بامب.
سبيد بامب. Okay. Let's see if we can do that or not. There is a condition here. It say that the location type, where can we apply these? But there's a criteria also for okay, the traffic constraints. Here, for example, the traffic circle, okay, is for volumes. If it's a local street, less than 7,500. If it's a non-residential collectors, okay, may be required to at intersections where residential collectors streets intersect. But for roundabouts, if the daily volume is less than 20,000, we can apply roundabouts. Speed humps, speed lumps, okay, it's a across the board that the average daily traffic must be less than 4,000 vehicles per hour, and the speed limit less than 30 miles per hour. Can we do speed bump on Khalid ibn Walid Street? Shabab, based on these conditions, which one will be more feasible? roundabout or one of these?
Speed humps and speed lumps
Yes.
better than
See the
roundabout.
volume? That's a major collector. That street is a major collector. The volume per day is much greater than 4,000. Okay? The volume per day is greater than 4,000. So roundabout in this case will be more relevant. And also for speed within 45 miles per hour. Here for speed 30 miles per hour. That means it's almost 50 kilometers per hour the speed.
But doctor, do we have enough space for the roundabout?
That's excellent question. That's the problem. Do we have enough space for a roundabout or not? Okay. So we might have, and we might not. If we don't have sufficient space for a roundabout, okay, then we might go to target speed enforcement. Okay, that's another option. But again, this is for low volume, low speed. So you have to keep working around these and make the right selection for the right location for the true problem that you are trying to solve. You see, so we don't go just jumping to, okay, put the speed hump. No, doesn't work this way. Okay. However, I have seen on that street there are raised crosswalks at several locations. Okay, so there are some speed raised crosswalks in several locations on that street. Okay, so that's one of the issues. So again, as I mentioned, for the problem we make a selection. Which treatment, which technique will be useful to mitigate the problem. For example, for traffic volume, none of these is that efficient. But vertical measures is great for traffic volume, forcing the volume to drop down. And yesterday we showed that the presence of a speed hump reduce the capacity of the road at the speed hump. It creates a bottleneck. And we showed that with numbers. If the problem was pedestrian safety, then we go with the raised crosswalks or raised intersections. So for each problem, there is a special, the favorite treatment. For vehicle accidents, you have traffic circles and roundabouts. Okay? Any questions so far? Okay, now the location of implementation. Here we discussed the different potential locations. And for residential neighborhoods, we have mid-block at intersections or boundary area. In non-residential, we have mid-block and at intersection. So here, for non-physical, you can apply it anywhere. But for edge line, center line striping, that's in mid-block. Okay, optical speed bars in mid-block. Speed limit signage, in all locations, that's applicable. Truck restriction signs, of course, it's nonsense to put it in the mid-block or at the intersection. You put it at the boundary, because that's an entry. So you are restricting or, prohibiting trucks from going through that neighborhood. For cross traffic does not stop. Usually this is at boundary areas. Okay. Again, for narrowing measures, okay, Narrowing measures, for the bulb outs, we use it at intersections. And I showed you yesterday an example for an intersection in the city of Raleigh in North Carolina, USA. Here, 2-lane chokers, usually that's in the mid-block. Okay, the central island, it can be anywhere, mid-block or intersection or at the boundary area. So this table gives you a guideline on where you can use that specific measure. Okay, for example, traffic circles, that's within the intersection in residential area. Roundabouts, single lane roundabout in non-residential area at intersections. Okay, lateral shifts, okay, that's mid-block, and so on. Any questions? So again, now we discussed that for each traffic problem, okay, we have these tables that we have for each problem. We have the relevant traffic calming measure, okay, and all of these measures, they have the location implementation where this needs to be implemented, okay, and here these are the constraints for implementation. That means you cannot just use it and implement it. No, we have to pay attention to the average daily traffic volume or the traffic volume of that segment and the speed limit, okay, and take into consideration other factors like bus or emergency response route and other considerations that are going to be listed in this column. I'm going to make a copy of this and send it to you, and send you a homework, case studies that you will decide which traffic measure that you can use to solve the problem. Any questions so far? So this, again, we mentioned this is an example for a pulp out. Okay, this is an example for narrowing or lane chokers in mid-block, as you can see. This is central island. Actually, we have here a combination between a central island, okay, speed hump, or raised pedestrian crossing. You see this, there is a slope, and you can see that this slope is a gentle slope. Okay, it gives even the driver, a sense that there is a pedestrian crossing here, or it alerts the driver to the presence of a pedestrian crossing. And here, that's two pictures for the same road. That's before and that's after. As we can see here, the lane width was just unmanaged. It was extra lane width, so here it got reduced and narrowed down, and we have an island in the middle, and we have a bike lane on the side, as you can see. So now the situation is different. This forced drivers to slow down. This wide range allow drivers to drive fast, and this is not desirable in residential areas. That's an example for a roundabout, okay, and we are not going to elaborate on that. We have a whole module about roundabouts. This is the traffic circle. The difference, one of you asked me yesterday, what is the difference between traffic circle and roundabout or modern roundabout? There is a significant difference between both. The only one common thing between both is that it has a raised central island and apron, but the rest of the elements are not there. For example, in roundabout, we have this geometry that forces drivers to slow down. In traffic circles, this does not exist. In roundabout, we have a splitter island designed in a geometry that does not allow drivers, to make opposite turns and several issues. In traffic circles, these are the splitter island. it's not similar to the splitter islands that we had in the roundabout, and so on. Clear يا شباب? Okay. Here, the third category, which is basically the horizontal measure, or the second category, horizontal measures, lateral shifts. As you can see, instead of keeping this road straight this way, there is a shift in the direction. This shift forced drivers to slow down. There is the chickens, okay, which are basically small lumps in the lanes, and these force drivers to slow down, or they claim that it forced drivers to slow down. This is another example for chickens that we had before. There is a non-physical measures. The non-physical measures are basically similar to this. The speed limit is 25 miles per hour. This is signage, okay, and there is usually a radar or speed radar, with this. Like here, for example, let's say the speed limit is 25 and your speed is 23. So it alerts drivers if they are exceeding the speed limit. Here the pavement is striping, more clear striping, okay, for pedestrian crossing, for example. So that's an example for that. Now for the vertical measures. The vertical measures are, speed bumps, similar to these. These are speed humps. Speed bumps and speed humps, they differ in the severity and in the length. So that's an example for a speed bump, and that's example for a speed hump. The height might be the same, okay, h and h, but the length here we have L1, here we have L2, greater than L1 significantly. This one is smooth for vehicles, and especially for those sports vehicles, because they have they are low to the ground. So with the speed bump, they might scratch the base of the car. This is a speed table, and it's a speed table and raised pedestrian crossing in the mean way. And as you can see, there's bulb outs. So here we have an integration between bulb out, speed table, raised pedestrian crossing, all together in one location. By the way, these are good, but we have to be careful, especially for stormwater drainage. Okay, so the way it's shaped here, this is not right. There must be a way for the rainwater to cross between the two sides. Okay, so the divergence measures, these are the last category. The divergence measures are basically either full road closure, okay, dead end, or partial road closure, as we can see here, okay, or diagonal lane closure, that within the neighborhood itself we go and make this diagonal barrier to prevent vehicles using this as a parallel route. Okay, there is also the median barrier. The median barrier is by making a median to prevent vehicles from directly making access to a local street. They need to go and make a U-turn, then come back and enter that neighborhood. Okay, this way it reduces exposure to accidents, and for only people that living in this neighborhood will be willing to make this maneuver. But people that are passing by, they are not going to be they are going to be hesitant to make this go through maneuver. That's example for forced turn exit. That means if someone exiting from here, they are not going to be willing to go this way. They are going to be and also vehicles entering from here, no. Okay, so that's it for yes, we discussed the speed hump and the impact of speed hump on traffic capacity, and we showed here that was the traffic flow or the flow density relationship without the speed hump. That's the new speed hump, okay, and this is basically the drop in capacity. And we showed here an example for or dropping the level of service, because basically V over C will be different in this situation. And we showed here that for the same volume in this example that we had a speed hump that drops the speed to 40, and we showed that without the speed hump, that was the level of service B. With the speed hump, basically the volume stayed the same, but the speed here got reduced to this value, and we ended up with high density and much lower level of service. Any questions so far? Okay, I'm going to give you some hints about module 5, which is basically traffic flow theory and shockwave analysis. So this is basically the beginning of advanced traffic flow and shockwave analysis, and we are going to start with macroscopic traffic flow models, okay, which is basically the relationship between the flow rate and the density, and these are the speed density, the speed flow rate relationship. Here the speed density models, and we will derive from the speed density models the different the equation for the flow density relationship. Any questions so far? Okay, we are gonna stop here, and let me just take the attendance.